I'm going to start at page 6, though. 6.
No.
7. Now, if you kind of cover up the bottom of your paper, so you're going to see the top half, like what's on the board. This is what a proof question looks like. It'll give you a picture. It will tell you some stuff that's already true about the picture. And then it's going to ask you to prove something. Okay? So now, let's look at the bottom half. This is what a proof answer could look like. Okay? Notice that this picture has lots of marks on it. Does everybody agree?
Yep.
Did the picture up at the top have any marks on it? No. Okay. Now, this is a graphic organizer. This is not the only way to organize a proof, but I find it to be the easiest method for the young people here in the room. These are, we did this a little bit with angles, statement reason pairs, like why is this angle whatever many degrees? Because a triangle has 180 degrees in it. Does that make sense? Like we're going to do these things. Does anybody see anything familiar up here? Anything they've seen before? What do you see? Bisect. Cool. What else do we see? Reflexive. What else do we see? Lots of congruent. What else do we see? Side to side. Now, you guys have not seen this before. We're going to get there. There's lots of things we're going to get to. We are dipping our toe in the water. But it's not, and ready? Never do I expect everyone to be perfect at every type of proof that we're ever going to do this year. That's not a realistic expectation. Do you try? Yeah. Yes. And can everybody do some? Yeah. Yes. If you do none, you are selling yourself short. So I'm going to go on. This is lesson 2. We're going to do proofs, and every single proof will have reflexive sides. Today that means after today, everybody should always be able to do reflexive sides. With me? All right. So here we go. So the first thing is how to write a 2-column proof. 1. We're going to, I gotta move that. Set up a statement reason table. Sometimes it's called a 2-column proof. Oh, I wrote that right up here. See that? 2-column proof. So this is why you picked up a straight edge, a ruler. Because what you're going to do with your ruler is this. You're going to go, you don't need much room underneath here, so you go across like that. And then you go down like that. I just made 2 columns, didn't I? And I'm going to write the word statements. Hold on, Mr. Can you slow down a bit? Well, I'm going to pause after I do this. You need to have the end goal in mind. Does that make sense? You need to have enough room to write the word statements and then write the word reasons. You're going to take up the whole area with that. Do you see how I went all the way to the next thing? I have to take this off because it's. Yeah, I got it. Sure, of course. Does anybody need a demo done on their paper for how to set that up? No. Okay, beautiful. Next. Read. That's the word read. That doesn't look like the word read. Read the goal, which is the word prove. Read the givens. Or the given. The given. Like if I have more than one. Okay, so I'm just going to pause, let you write that down. Okay. Give me a high five or a thumbs up when you're ready to listen. Good, good, good. Okay, great. Here we go. See, everybody find the word prove. What does this say?
Prove triangle ABC is congruent to triangle ABD.
Okay, so now look at the picture. Find the triangles. Ooh. ABC, ABD. Cool. Does everybody understand what our goal is?
Yeah.
Cool. That's the goal. Now let's look at what the given is. What did they tell us is already true? Given. AC is congruent to AD. Mark it on your picture. We mark it with tick marks. AC is congruent to AD. Cool. Okay, now I read the next part of the given. CB is congruent to DB. How do I mark it?
Double hash marks.
Double tick marks, yep.
Because if you do single, then it will mean that all four of those are congruent. And if you do the double,
Yep.
then it side splits apart.
Yep, very good. Okay.
That AC and CB are congruent.
Now we're gonna okay, so wait. We need to write down another step here. Did we mark the picture? Mark. Oh my gosh, what's wrong? Mark diagram. And then we are going to take a moment of silence to brainstorm, aka think. So you're taking a moment to brainstorm and think, and you look at the picture and you think, you're not talking out loud yet. Is there something else I can mark on that picture because, oh, that's cool. Well, I want to prove triangles congruent. How many different ways can I prove triangles congruent? Oh, do I know which way I'm going to use? We're brainstorming. Do people have ideas in their head?
Yes.
Okay. Okay, so we look at the name of the lesson. It says proofs with reflexive sides. Does everybody have an idea in their head?
Yes.
Tyler?
I have
Reflexive side.
I have an idea.
Oh! Okay, great. And what are we trying to prove? We're trying to prove triangles congruent.
Triangle ABC is.
Dude, you have to be quiet because you're not the only person in the room. Everybody thinks slower than you, including me. So zip it. Good Lord. Okay? You have to pause and think. But we do have another step to start off with. Here we go. The first statement goes with the first reason. So we number our statement reason pairs to keep ourselves organized. Now, the first reason is always the stuff that is given to you as true. This is a copying task, which requires very little brain cell work. Copy. AC is congruent to AD. CB is congruent to DB. Now, I can mark some more stuff on my picture if I want to. In fact, I'm going to do this. I have my first set of sides. I have my second set of sides. So since I'm talking about the reflexive property, what might I want to do on my picture? Mark the reflexive side. So what, do I now have my third set of reflexive sides?
Yeah.
So for third pair of sides, yes. Now it's on the picture, but is it in the proof yet?
No.
No. So here we go.
S.
Not yet. Because right now, do we only have S and S?
Yeah.
So we need to put A, B is congruent to itself. A, B. Now this line right here is kind of like the word because or the word why. Why can we say AB is congruent to AB? Because of the reflexive property. So you can put just the word reflexive, or you can put the reflexive PROP, which stands for property. Either one would get you full credit. So now, here in my proof, do I have a side, and a side?
Yes.
So now, can I complete my goal?
Yes.
Yes. So step 3 is triangle ABC is congruent to triangle ABD by side, side, side. By side, side, side.
Good job, Jason.
That is a completed proof. So we started out with some statements and a picture, and then we had a goal, and we provided the last piece of information necessary to prove that these triangles are congruent. Okay, let's do the second one, and then we'll do our 3x5 cards. Okay, here we go. So we have to set up our statement reason table. On your mark, get set, draw a T-chart. Does everyone have a T-chart? Okay. What is our goal? What are we trying to prove? I know you know, Luca. Hang on.
Thanks.
Okay, very good. Amir. Okay, so that definitely is true. What is our goal? What are we trying to prove?
Trying to prove JLM is congruent to LM.
Very good. So we're trying to prove, and so this picture is very simple, correct? Does everybody only see 2 triangles? Yeah. So it's very easy to say, oh, I'm trying to prove that this triangle is equal to that triangle, right? Okay, so now let's go to the givens. They told me JM is congruent to LM. Go ahead and mark that on your picture. You mark it with ticks, right? JM, did I say LN? NM. I'm sorry, I'm having trouble with my letters.
It's okay.
JM, okay, Luca, I love you. You're very polite. Okay, great. There it is. Now, the next thing says that L is the midpoint of JN. So L is the midpoint. And once again, I'm going to use some highlighters just so everybody sees what I'm talking about. JN. Now, technically, that's going to mean something, but do we know it right now? I mean, we know it, but do we know it? Is it in the proof yet? It's not there yet. So we're going to get there. Okay, so let's write our givens in our proof. J, and you're literally just copying them down. Okay, I abbreviate the word midpoint. MIDPT. That is an acceptable abbreviation. And sometimes you have to kind of squeeze it in, and it's okay. You'll have plenty of room. Okay. Now, we brainstorm. Right now, however, the only thing that's in our proof is this set of sides. Do you guys agree with that? It's the only thing in there. All right. Mr. Luca, you can give me one thing you want me to do in the proof. Go.
Okay, so if it's a midpoint of something, it splits it in half, which means JL is congruent to LN. So
okay, so pause there for me. Good. So you're right, 100% right. So because this is the midpoint, this guy is cut in half. So I'm going to use tick marks, right? So I'm going to keep reminding you about which things are tick marks and which things are angles with arcs. So we can write the statement JL is congruent to LN. So right now, this is only half done. We only have the statement, and we need statement reason pairs. So this is why we're going to do flashcards to help us, okay? So we're going to do them all at the end. We're going to finish this proof. There's specific words that we have to write here to back up our evidence, essentially. But really, it's not just say what you see, okay? What were we given? We were given a midpoint. What does a midpoint do? A midpoint, what does it do? It divides. What does it divide? Oh, it divides a segment into two congruent, so we could use the symbol, segments. That's now a complete segment reason pair. Okay? All right. Ooh, can I put this here? Ooh, I'm heading towards my goal. SS, but I can't, that's not enough, is it?
SSS.
How can I get my third S?
X.
Well, what's the X mean?
X. It means another side.
It means another side. What's the reason for the other side?
They share the same side.
Okay, so what's the reason? What do I write right here?
Because triangle.
Just look up at your previous example.
Yeah.
Look at where we have it just starts with the letter R. Reflexive property. It's gonna be okay. Tyler, can you tell me how I write down the statement for the reflexive property? What do I have to say is equal to itself? What did I put the X on? Yeah. Yeah, LM, give it a tat, is congruent to LM. So when we use reflexive property, we're always going to have something is equal to itself. And all of the stuff on this side is specific for this triangle. All the stuff that's over here is very generic, like definitions. Okay, do I now have enough evidence?
Yes, we do.
All right, so let's finish this proof. And we'll do our flashcards, and that will be as far as we get today in our packet, and that's A-okay.
It is.
Well, I said that I wanted to do some delta math with you in a little bit, and we have to do our flashcards yet. Okay, so do you have your last statement down, Jason? Come on, stay focused. Because you don't need me to write it for you, because it's right up here, isn't it?
Yeah.
Yeah, so you don't need me to model it for you. It's right there. You're closing the door.
I got it.
Okay, now don't put this away yet, because you need it to help you write your 3x5 cards. So you're going to keep this paper open. And now you're going to grab your 3x5 cards. I think we're going to need 3 of them right now. That's it. Okay. So I'm going to have this as a running document in the Google Classroom in case you you miss a day. But basically, and then you might have to do these on your own. And if you need more cards, I can get you more cards. But basically, the left side is always going to be the front of the card, and the back side is going to be kind of the thing that we need to remember. Okay, so first card. I'm going to draw, insert a triangle. Okay, I'm hopefully this good. Oh, that's just, woo, look at that pretty triangle. There we go. That's a nice looking triangle. And I'm going to draw a line down the middle. kind of like what we saw, I think, in one of our pictures. Okay, so the front of my first card is going to look like that, but better. Oh, that's not really nicely drawn. Got to fix that. Sorry, give me a second. That's better. Something like that.
Do I put the X through it?
So this is gonna, so pause. Now this is where you get to personalize your card. What's gonna help you? Definitely on the back, I am gonna write reflexive property. I should probably put the word property for those people that are not here. Okay. Now, it's totally up to you what you think. I probably would put the X on the front. So I put this X on my front. You know, maybe I even do something like this. Like this is, I think we had an L and an M, right? Something like that. And we can say LM is congruent to LM. Right? We just want an example that we have to, and then I don't know where you want to put this. You have to see it. See it, right? Like, that's the deal. It's not going to be there. You have to see it. Okay. Okay, so reflexive property. We might be only doing 2 cards, actually. Now I think about this. Okay, so then, and this is for you, and if you don't like it, could you always redo it and make it different? Does that make sense? I'm giving you my ideas of what I would do. So then the second one, this is what would help me. We were given that reason L is the midpoint of, and I forgot what the line was.
JN.
JN, thank you. JN.
Do I write that on the side for my triangle?
So, no. So this, I'm sorry, this is now flashcard number 2. I didn't make that very obvious,
okay.
did I?
No, it's
okay. This is flashcard number 2. Okay. So for me, I don't really need, like, I kind of am like, I can figure out that this is going to be congruent to that part. That's pretty easy. The part I need on the other side is what I write for the reason side. So on the opposite side, I would write a midpoint divides a segment, because this was a segment, into 2 congruent segments. And so as we go from proof to proof, if you kind of start to make yourself a set of flashcards that you can kind of look through, or even if you only have, like, you might not need to do back and forth. Sometimes you do, right? It depends what you're doing and trying to say. If you're at home and you're working on a proof and you see a proof that has the word midpoint on it, right? You might go, and if you, wait, actually what you could do, where was this an example? What page? What page are we on in our notes? Page 7. You might put down page 7 right here, so you have knowledge of where to go for an example even, right? Yes, sir.
It's 12:55. I forgot the map.
Yes, I'm aware. So, does that make sense? How we can use these flashcards to help us learn these, like the idea of how we make statement reason pairs? Okay. I don't want to make it laborsome. I want to make it helpful. Are you guys good? We're going to stop with that part there. We're stopping with the lesson there. We're going to get Chromebooks out, and I need to show you something new in Delta Math. Okay? And then you have a short Delta Math assignment over the weekend. No crying in math class. Agreed?
Yep.
Okay. There it is. A little bit more. Okay, here we go. So we are in Delta Math, and we're starting off nice and slow, and I'm doing these first ones with you. So when we go into this, all of these except for the very end are singletons. Does that make sense to everybody? We all get the same questions. So when you go into a question, that's the first thing. There are videos about this, but I don't know if that would be helpful. But I want you to kind of see what's going on. Does everybody recognize this? Like, hey, we have a given, we have a proof statement. Hey, I only see 2 triangles, right? Everybody good so far? Okay. So they're going to start the proof. And like, notice how if I hover over something, do you see how it just lit up those yellow angles at the bottom? And I go away. This one is already there, and that is in set of angles that is given, right? So we have an A. Okay, so does everybody see reflexive property? Let's just start off with what our lesson was for today. Okay, so when you go into the type of statement, reflexive property, it doesn't have the right letters. But do you see how we want to do a segment congruent to a segment? Okay, so you pick that shell. All right, what is the segment we want to say? Well, it's AC. So I type in capital letters, AC, and then I go to the next box. A lot of kids like to use the tab key for that, AC. And now there's going to be a bank of reasons. Now you can, there's things in here you have never heard about, and that's okay. You can search. So for example, if I put the word angle in here, do you see how like I'm starting to get things that only have the word angle in them? So you can search within the bank, but we can see what we need, right?
Yeah.
So we pick reflexive property and then hit the button that says try. If you are correct, it will let you go forward. And this is why there's no crying about this. Okay, we're just going to try to do our best. Now, we did not get to today's example about a bisected angle, but we can figure this out, right? Because when I hover over it, does everybody see the 2 angles we're talking about? Okay, so the first thing is, we know we want to say an angle is congruent to an angle. So you're going to choose that shell. Now, the problem is, and I'm going to go back and hover, can we call those angles angle A?
No.
No, we have to use 3 letters, but the middle letter will always be A. So the one, I can start one of them with the letter B, and it's going to be angle BAC. Good. BAC. DAC, very good. Okay, so I can, do you guys agree that BAC and DAC are correct? Good. Now I'm going to go over to the reasons. And once again, there's a lot of stuff there. You can either start to read down through it, or I think if I type in the word angle, let's see if it does it for me. Yes. Do you see how I start to put the word angle in? And things start to pop up that only say angles. Well, it's not vertical angles, it's not right angles, but look at this. Nope, not there. Oh, the 4th one down. Or what? Do you guys all see the words an angle bisector? Angle bisector divides an angle into 2 congruent angles. That's going to be one of our flashcards soon. Okay? So we tap that. We say try.
Try.
Cool. So let's look at our triangles. We have a set of congruent angles, a set of sides, and another set of congruent angles. So do we have enough to say the triangles are congruent?
Yes.
So we go and we pick the triangle congruent to triangle statement, and we just type in the letters that are up here at the top. Now, notice how like it didn't pull up all those crazy reasons we had before. It pulled up the reasons that we might use. Do you guys agree? Now, take a look at your picture carefully. Is it angle, side, angle, or angle, angle, side?
Side.
Very good. Angle, angle, side. Because it's not the side in between the 2 angles. Say try. And then did you notice it light up? And then say submit your answer. Gosh, I hope we all got it right. Okay, and then like say, folks, say you do not get one of these rights. Do you see how you can click through the steps? And they did it in the opposite order, but guess what? Do we still all have the same answer?
Yeah.
Okay, so let's go to the next problem. Okay. Is this the same thing? Slightly different. Slightly different. Okay, we have CA bisects BAD. We have AD, or is congruent to AB. All right. Do you guys want to do reflexive property first?
Yeah.
Okay, so that means I need congruent segments. This part is the exact same thing. AC, AC. And if you do a thing about segments, it's only going to bring up things about segments. Okay, so reflexive. And you hit try, and it goes in. Okay, so now here I am again. I'm going to hover over that reason. And it's not up here where you can hover. It's in the proof where you can hover. Do you guys see the angles we need to put in? Okay.
We can put in.
I think it's the same exact, is it the same angles as last time?
Yeah.
Oh, well, isn't that convenient? That was not planned. BAC and DAC. Okay. Now, again, this happens to be an angle bisector. So when we do this by hand, we're going to write the word arcs above that so we can remember to put arcs on our picture. And I need to find it. Angle bisector. Okay, and I'm going to hit try. Okay. Well, our triangles are now congruent, but is it the same reason as last time? No, right? Because we don't have two angles. We have two sides.
So side.
Ooh, can we do side angle?
Side angle side.
HL.
Yeah. No, we can't do HL here. There's no right angles here. Okay, folks, look at side and a side and what's in between it?
Angle.
Angle. You said side angle, didn't you?
I said side.
All right. It's going to be okay, everybody. Get the triangle one. Type it in. ABC, ADL, ADC, and this time it's side angle side. And say try, and it flashes. Oh, it's so happy. All right, so submit your answer and say yes.
We're not done until 1 o'clock.
I know, it's 1:06.
That's what we should do another one.
So we're doing good.
Yeah, I know.
Okay, I was like, I really wanted, these are your first time doing these in here, and so I wanted to make sure everybody felt, and I'm trying to make sure I pick ones that I know you can do. And it's okay if, like, you don't get, okay, so now we got something a little bit more exciting. Ah! All right, but we've done midpoint, haven't we, folks? Okay, so let's go here. So midpoint, does it give you anything? It doesn't. Okay, but for the angles, there's one set of angles. There's the second set of angles. So we got to deal with the midpoint. The midpoint is D. It's down here. What do you guys think we need to do? What did midpoint give us? Did it give us congruent angles or congruent segments?
Congruent angles.
Think about what a midpoint is.
Is that our angle you're pointing at?
Okay, I am pointing at point D, which is the midpoint of AC. So I can't, when I hover over it, it's not highlighting anything like these ones did. That's too bad. But D is the midpoint of AC. That means I'm cutting the segment in half or into two congruent segments. You missed the flashcard piece. You need to make sure you get that done.
All right, that's the question.
Okay, so now here, hold on, what? You have to ask me a question?
I was asking.
Yes, for a flashcard.
Oh, flashcards.
I got you.
They're also going to be in the Google Classroom. Do this with us.
They're gonna be
All right, I was
good.
good when I go.
Yes, very good. Okay, here we go. AD, right? AD and DC. The order of the letters does not matter. Now, this might be a little bit more exciting. Let's see what happens when we tap on that. If it doesn't come up right away, would you type in the word midpoint? Whoa, there's only one that says midpoint, right? And the more times you say that out loud or in your head, the easier it's going to be. It's just a definition, isn't it? Okay, let's try it. Ba-bam! Oh, yeah. Cool. So look it, we have a side and we have two angles. Can we say the triangles are congruent? Yep. So let's get our triangle congruence and then make sure you get the names of the triangles from up above. If you mistype, it will give you an error. Then just go back. Don't fret. Go back and look and see what you typed. Okay. What is this one going to be? What's our method?
Angle, side.
Okay, careful.
No.
I have an angle and I have an angle. Is it the side in between the two angles? Is it the side between the two angles?
Angle, side, angle.
Okay.
No.
You're not. So this is okay. Friends, this is why this is hard. Do you see how I have these two angles? These angles make side ED. Do I have ED in the proof?
No.
No, I have AD in the proof, right? So it's going to be angle, angle, side. But does it, I need to make sure it makes sense. Does that make sense? Okay. So friends, I know I'm being like a crazy person about this, but you can do this. This is the easy part. Okay. So angle, angle, side. All right. So we have to say try, then we can say submit, and we can say we're awesome. Okay. So now the remaining part of this is having you, so you're going to need to make sure you read, and you might need to use a piece of paper to draw it, okay? But you're going to, it's like a fill in the blank. Do you see how that? Rotation, what am I doing? I'm going to do what? Reflection. So this is making a nice connection to our last unit, okay? There are 3 questions. Guess what? There's one for rotation, one for reflection, one for translation. Oh, Miss Rupp, you're terrible. Does this have examples you could look at? Yes. Or a video you could look at? Yes. Do you see how they're doing examples for each of them? And then guess what? They do like a crap load of examples. There's rotation, there's reflection. They're all in here. Thousands of examples. Okay, great. Beautiful. Then you're going to have one proof. Oh my gosh, with angle puzzles. Remember the angle puzzle proofs? You're going to try one. And then the last thing is just the triangle criteria. The SSS, side angle side, side angle side, angle, all that. Okay? So you should have about 15 minutes left on this assignment.
Yes.
Yes, this is now your homework. Because we are at 1:10, class ends in 2 minutes, which means you need to make sure you have enough time to clean up and make sure that we don't leave any gum garbage on the floor.
Me?
Last week there was gum garbage on the floor.
What table? This thing?
It was like one was there. I don't know who did it.
I think
It's the party people.
I mean, it's a party all the time.
Well, no. I mean, everybody's a party here. Okay,
So we're leaving.
are we good?
Yeah.
Great.
Okay, are you going to do it?
With
Never.
our class.